Hey, what's up everybody? My name is Takuma Matsui here with 343 Labs in New York City. In this video today, we're going to be talking about modular synthesizers, basically a build-your-own synthesizer playground. We're going to take the basic building blocks of synthesizers like oscillators, filters, and envelope generators and patch it together in a custom configuration. So in this video, we're going to be walking through how a basic subtractive voice is put together, and we're going to be using a free Eurorack simulator called VCV Rack 2. To follow along with me in this video, you can download the links below where I'm going to be walking through different patches, and also download VCV Rack 2 from vcvrack.com. Alright, let's get started. So for this tutorial, I'm going to be starting out with a subtractive patch that I already put together labeled subtractive voice. Let's check out how this is configured. So this patch is actually quite simple. If you've played around with any synthesizers, hardware or software, you can probably recognize some of the components. The first thing that I want to mention is that signal moves from left to right. So we're starting with our MIDI input using this device called MIDI CV, and ending up with the audio output with this audio module on the right. In between, there's a couple things. First is an oscillator. Right now it's playing a sawtooth wave. If we change this to a square wave, you can hear that the timbre changes. This is followed by a filter. Right now this is a low pass filter. If we open up the filter cutoff, you can brighten up or dull down the timbre of this patch. This is followed by an ADSR envelope that shapes the timbre over time. I can elongate the attack time or elongate the release time. I can also kill the sustain and the release to create more of a plucked sound. And finally, this is followed by our output. So what I'm going to do now is I'm going to clear out this patch, and I'm going to build the same thing from the ground up. So let's start by adding some modules. I'm going to control click to see all of the modules that are available. And I'm going to start out with my MIDI input. I'm going to search here MIDI. And here's the module I'm looking for, MIDI to CV. You can see that there's other modules that are similarly named, MIDI CC to CV, MIDI to gate, CV to MIDI, but the one I'm looking for is this one, MIDI to CV. I want the signal to move from left to right, so I'm going to keep this here. And also let's designate an audio output. Again, I'm going to control click. I'm going to type in audio. Since this is going to be our output, I'm going to pop this to the right. Right now I'm recording this screen, so I'm going to be designating this as multi-output device. In your case, you can use external headphones or your audio interface output. And let's also designate our MIDI input here. I'm going to select Arturia Minilav Mark II. Let's start off with our source of sound, or the oscillator, which creates constant oscillations. I'm going to control click again. And because all of this is voltage controlled, I'm going to be looking for voltage controlled oscillator, or VCO. Here's our VCO. Let's keep this in. So let's hear what this sounds like. I'm going to take my sine output and connect it to my audio 2 mono input. We hear a simple sine wave. I'm going to turn this down for a second. Using the frequency knob, we can control the pitch. And that's all this does. Let's disconnect this for a second. Right now, our synthesizer doesn't know what pitch to play because we haven't made that connection with our MIDI keyboard. I'm going to head on back to my MIDI CV device, and I'm going to take my volts per octave output and connect it to my volts per octave input on my VCO. Now again, let's connect our sine output to our mono input. Now if I press on the keys, now it's receiving pitch information. So volts per octave is unique to modular synthesizers. It takes MIDI pitch information and converts it to pitch information that your rack modules can understand. If I add in a scope module and connect our volts per octave to a scope, let's connect this again. You can see that C3 here is 0 volts, while the next octave up is 1 volt, another octave up, and it's 2 volts. Pretty simple. So this is cool. Now we have our synthesizer playing pitch. But right now, there's no way to stop our audio aside from disconnecting it from our audio module. To remedy this, I'm going to add a voltage controlled amplifier, or VCA, in between our oscillator and our output unit. Again, I'm going to control click, and let's type in VCA for voltage controlled amplifier, and here it is. And now I'm going to take our oscillator, connect it into our VCA, and take the output of the VCA and connect it back into our audio unit input. The VCA is basically a fader. I can pull this down. And for now, that'll turn off the audio. Now, what I want to do is have the fader respond to the note on or note off message from our MIDI keyboard. For this, I'm going to go to the gate output and connect it into this empty slot, CV input of our VCA. I'm going to turn up the fader amount for the VCA. And now if I press on a note, now it's starting to feel like an instrument. The note plays when I play on the note and turns off when I let go. The gate signal is something that's also a little bit unique to modular synthesizers. I'm going to take my gate output and visualize it using the scope. You can see that the gate signal is acting as an on-off switch, and that's exactly what we're hearing from our keyboard. What I want to do is turn this gate signal into something that's a little bit nuanced using an envelope generator. For this, let's control click again and look for an ADSR envelope. This ADSR envelope generator takes this crude on-off information from our gate input and creates a more nuanced envelope. I'm going to take our gate signal from our VCA and connect it into the gate input of my ADSR and take the envelope output and connect it back into my CVN of my VCA. Now here's what we get. So this is starting to feel like a real instrument. To finish this subtractive voice, I'm going to add a filter so that we can subtract or take away energy from our signal. Following the naming convention, I'm going to control click, and we're looking for voltage controlled filter, or VCF. And following signal path, I'm going to put this in between the VCO and our VCA. Let's tidy this up. So you can see that in our signal flow, our VCO is completely skipping the VCF and going straight into the VCA. I'm going to disconnect this for a second. I'm going to take our VCO output and connect it into our VCF input. I want to dampen this sound by taking the high frequencies away. So I'm going to take our low pass filter, or LPF output, and connect it back into our VCA output. Now you can hear that if I open up this filter cutoff, so the big question now is, why are we putting in all of this work just to get such simple sounds out of the synthesizer? The real fun of Eurorack starts when we start breaking the patch that we just created. I'm going to start by taking this ADSR envelope generator. Right now, if I connect this to the scope, It's creating this basic envelope shape that we're using to move the fader of our VCA. I'm gonna make a new connection from our ADSR envelope by holding Command and clicking to create a new connection, and connect it into our cutoff input of our VCF. Now this input lets us control the filter cutoff of our VCF using other voltages. This little knob is the modulation amount, or how much we want to move this filter. Let's turn this up. We can also use this envelope to control the pitch of our VCO. Again, I'm using Command click to create a new connection, and I'm going to connect it into frequency modulation input. Again, turning this modulation amount up will let us modulate or move this frequency dial using the envelope that's generated with our ADSR envelope. If we turn it the other way, so that was a lot of new stuff, so let's do a little recap. So today we built this simple subtractive patch using a VCO, an oscillator, VCF, a filter, and a VCA, an amplifier or a fader. We also looked at volts per octave, which takes pitch information from our MIDI keyboard and converts it into voltages. We also looked at gate signals, a on and off switch, which we shaped using an ADSR envelope generator. In the downloads folder, you'll also find some variations of this subtractive voice that you can poke around and see what's going on. In the next video, we're going to be exploring modulation using LFOs, other envelope generators, and audio rate modulation. Hope you found this video to be helpful. My name is Takuma Matsui, here with 343 Labs in New York City. For more information on our courses in New York, Berlin, or online, check us out at 343labs.com. See y'all next time.